Ok, rebonjour. Axel
We're back again. Axel Krein has joined us. He is on the line. He's a former Airbus executive, and now he works for the research program known as Cleansky, and he'll tell us how we can make headways on aircraft engines technology and using defossilized fuels. Guten Tag.
I'm very glad to be here today and thanks for the Academy for inviting me to give that presentation today. Obviously, the whole topic of this conference, air transport in crisis and the climate challenge, is extremely relevant for Cleansky, as you said already, and basically all aviation stakeholders in general. So I think it's a very interesting topic for such a conference, and I believe strongly that this is a window of opportunity for us to build aviation back together for a stronger, greener European aviation industry. And in my presentation today, I would like to tell you how Cleansky, how our program, how this European program as part of Horizon 2020 can contribute and can work towards this. Starting with the next slide, please. I would like to introduce Cleansky a bit to you. I think most of you are quite familiar with the topic matter, but for those of you who are not or who can't remember that well, maybe very briefly to tell you what Cleansky is about. So we are a 4 billion so-called public-private partnership between the European Commission and the private stakeholders, the private industry. And it's part of the Horizon 2020 program for research and innovation of the European Commission. We are developing innovative technologies for greener aircraft, as the name suggests already, focusing on more efficient wings, lighter structures, more efficient engines, smarter systems, new configurations, and also on sustainable aircraft life cycle. So you see here on the left-hand side, you see our targets, minus 20 to 30% reduction in CO2, in NOx and in noise. And in the middle of the slide here, you see all the contributors. We have more than 900, close to 950 contributors now, different entities participating. And you see here quite a range of entities from more than 300 industrial players, more than 350, 60 SMEs, 150 universities, and around 110 research centers. So quite a huge contribution from different parts of the stakeholdership, of the aviation stakeholdership all around Europe. And we have altogether roughly 5,000 scientists working on Cleansky topic matter. So quite a reasonable number of engineers and scientists from all over Europe, altogether 5,000 people working on it. These participants, as I said, are based all over Europe, so it's not one country. It's we're altogether having 30 countries, members of the European Union, but also associated countries. We have the aviation stakeholdership, but we also have people from the automotive sector contributing and sharing their experience with the aviation community and contributing to the success. I think altogether, this is showing that the aviation community in Europe is a very, very powerful body, a very powerful network, and that's what we are very proud of and we would like to sustain. So on top of the technologies themselves, we are also proud of the network which we have been able to establish over the last decade. Next slide, please. If you please go to the next slide. Yeah, thank you. You see here the major demonstrators, and those are 34 which we qualify as major demonstrators, and I obviously don't want to touch upon each of them. I think people who are part of that demonstrator areas, you know exactly what's going on. Maybe just a few highlights. We have here on the aircraft configurations, we have the next generation tilt rotor demonstrator or racer, a new compound rotorcraft. We have hybrid laminar and natural laminar flow demonstrators. On the propulsion side, we have ultra-high bypass ratio concepts, architectures for regional turboprops. On the system side, new environmental control systems demonstrators, also some demonstration areas focusing on electrical power generation and distribution. And last but not least, a big demonstrator as well on the fuselage side called multifunctional fuselage demonstrator, an 8-meter long fuselage barrel, which targets a weight reduction of 1 ton overall and a cost reduction of $1 million per ship set. So significant demonstration areas, and we are entering now into a phase. We are roughly 2/3 through the program. We are entering now into a phase where those demonstrators are going to be in the foreground. Up to now, it was more basic technology, working on those technologies, bringing them to the next stages, and now we are entering into the final demonstration phases over the next 3 years up to the end of the program. Next slide, please. I'd like to come now to the future, and when you look at the context basically we are in, you see here on the left-hand side a couple of key items like the Paris Agreement, like the ATAC, the Air Transport Action Group commitment, like the European Green Deal. All of those are definitely influencing our work and are going to influence significantly the future of those partnerships in the coming years. You see here in the middle of the slide the target which has been formulated by the European Green Deal. So a significant reduction in the CO2 emissions. You see those are going to go down, and what you can see here are net greenhouse gas emissions in Europe, which are going to be targeted to become zero, and that's the green dotted line, which you can see down there to the 0 point. For 2050, you can see as well that it is forecasted that the different lasagne elements still show that there is a minimal greenhouse gas emission at that time, but this is supposed to be absorbed by carbon removal technologies or improved land use. So net zero by 2050. And transport is the olive part in the middle, as you can see here, and obviously aviation is part of that middle part here. So the challenge is clearly formulated for everybody, from agriculture to industry to transportation and to aviation. I'd like to briefly come to the COVID impact. I think you probably have heard about that already, and if you are not in the middle of it in terms of COVID impact on aviation, you can see here a very, very drastic impact. And you see the Heathrow numbers, the London Heathrow passenger numbers between 2019, the blue line, and 2020, the red line. You see the dramatic drop in February, March last year, and only a very, very modest increase until the end of the year, 2020. It's predicted that the worldwide passenger numbers will be back to 2019 levels, not before 2024. So a really, really drastic and dramatic impact, and no other industry has been hit harder. At the beginning of this pandemic last year, what we did, we took immediate action for our participants, for our stakeholders. We deferred the deadline for the Call 11 at that very point in time, which was at that time running. So we accelerated and released pre-financing and payments for our project. And since then, we have been implementing various mitigation measures together with our partners from industry, research, unis, and SMEs. And we were able to continue delivering on our objectives. And we are thinking right now that with all those mitigation measures, we will be able to finish the program with the initially planned objectives. Of course, we need to continue to monitor the situation, and we need to see how COVID may impact the coming weeks and months on top of what we have seen already. But we are reasonably comfortable that we can maintain the objectives and can still deliver against those objectives which I've indicated to you at the beginning. Difficult times, but difficult times present us also with new opportunities. And I think this new opportunity is the European goal of climate neutrality by 2050. A huge challenge, but at the same time, and that's how we perceive it right now, a huge opportunity as well. And we at Cleansky, we are more determined than ever to build climate neutral aviation and to make climate neutral aviation a reality in support of that European Green Deal which has been formulated. Although, and this is a point, we have clearly to state that achieving those Clean Sky 2 objectives will definitely not be sufficient to achieve those new targets. So the challenge is quite clear and formulated. The question is now, what do we do? Can you please go to the next slide? Here I would like to highlight a few key features of our vision for climate neutral aviation by 2050 to you. And the graph on this slide shows the increase, the lasagne you can see there, the increase in worldwide CO2 emission over time up to 2050. So emissions will roughly triple between now and 2050 if no action is taken. ATAC, the Air Transport Action Group, I talked about that briefly, has taken a commitment to reduce the emission by 2050 by 50% versus 2005. And this is represented by the dark dotted blue line, which you can see there in the middle of the slide. Europe's target is more ambitious, and Europe's target is represented by the light blue dotted line, and this goes down to 0 by 2050. So what we have done is we have analyzed the different potential measures, and we have concluded that there are 3 major change drivers, and those are there on the right-hand side of the slide. First, reduction of fuel burn, and by that also reduction of emissions, and this could bring and should bring up to 50% of the target. So 50% coming from the reduction of fuel burn and the reduction of emissions, as you can see it here. 10% then by improved air traffic management and operations. This should be good for roughly 10. Then the big part on the bottom, new fuels, sustainable aviation fuels, including the usage, for example, of hydrogen, and I'll come back to the hydrogen topic in a minute, that could bring up to and around 40%. So 50, 10, and 40, those are the measures, and we think that implementing those measures will make sure that the CO2 emissions will not raise to the indicated number, but will be reduced to 0 by 2050. And what we think is that these measures could make 2019, so not last year, the year before last year, the peak year in absolute CO2 emissions from European aviation. A word to the timing, and you see the green writing on top of the slide there. If we want to be 0 emission by 2050, those new products cannot start to enter into the market only by 2040 or 2045. As you can imagine, the remaining time left up to 2050 would be too short to replace the then flying fleet and less environmentally friendly fleet. So we are considering that the time between now and end of this decade is really vital to develop, mature, and demonstrate the necessary technologies in order to allow those aircraft to start entering into service around 2035. And by that, have enough time to replace the older aircraft and make climate neutral aviation by 2050 a reality. You can see that highlighted there, that we consider the technology development needs to happen between now and end of this decade, with major demonstrators, being it ground or flight demonstrators, to be performed around 2027, 2028. And then the product development of those products need to be followed so that those products can then enter into service around 2035, maybe some of the smaller ones, maybe even a year or two before. Next slide, please. This slide shows data from DLR, the German Research Center, which was generated in the framework of the Clean Sky so-called technology evaluator. Following certain assumptions, I don't want to go into much detail here, but just indicating to you that following this technology evaluator, Clean Sky technology evaluator work, we come to the conclusion that by 2050, approximately 90% of all CO2 emissions, that's the upper part of the slide, will be generated by aircraft above 200 seats. And the lower part of the slide, that 60% of all CO2 emissions will be generated by flights below 3,000 kilometers. In conclusion, what the slide is saying, that we shall focus on technology development which can make rather large aircraft with a rather low range climate neutral, as this, according to that slide, is the sweet spot for our green ambition. Again, I don't want to really discuss those numbers now, whether it's exactly that number, whether it's exactly that profile, but I'm showing this slide as I believe it is very, very important to have the right approach to narrow down the most promising areas to attack our main problem, the CO2 emissions. And in this context, I do not believe that we can just extrapolate aircraft size and range requirements from the past. We will soon see CO2 emissions and fees per ton emitted far above what we know right now. When you look today at the European emission trading system, the price per ton emitted is roughly 40 euros right now, has been increasing significantly over the last months. And you may have read that Norway, for example, has just announced the cost of 200 tons per emitted 200 euro per ton emitted CO2 by 2030. So today, ETS 40, Norway indicating 200 by 2030. If you do the simple math and assume for a second that this 200 euro would become reality in the future, and then you take the predicted growth in CO2 emission without any major impact, this would make a bill for the airline industry of 500 billion euros. Impossible with annual profits of 30 billion euros. That would be far exceeding any benefit the airline industry is taking out of the ticket prices. So not sustainable at all. So my conclusion here is we will see likely new aircraft appearing in the market with a seat capacity of, let's say, less than 150 seats and a range of probably only 2,000 kilometers, because only those concepts are technically doable within this time frame. And airline routes may need to be adapted to the capabilities of those climate-neutral aircraft. So, for example, a stopover for a 4,000-kilometer flight is only then the total distance can be covered by climate-neutral flying. And I think that is definitely a point which I would like to put your attention on and draw your attention on, that the design is not anymore what is possible. The design should be following what needs to be done in order to make it climate neutral. The next slide, please. We have worked over the last year, probably 12 months, even 18 months, with various stakeholders of industry, research, universities, and very closely also with the European Commission. You see here that the more than private stakeholders from all around Europe, very different backgrounds, and you see the logos on the slide here, developed the so-called Strategic Research and Innovation Agenda, which is a high-level technical description of the work which need to be performed. And those more than 30 private entities have also expressed their financial commitment to the proposed Clean Aviation Partnership, which was proposed by the European Commission. And you may have read that just recently, about 2 weeks ago, the European Commission formally proposed that new Clean Aviation Partnership to the Council and to the Parliament. They need to comment on those, and we are hoping an alignment can be reached around autumn, so that by late autumn of this year we can launch the new partnership for clean aviation. Next slide, please. And here I would like to share with you a few items which are being considered as the core of the core, which should be part of that new Clean Aviation Partnership, and which should be the focus areas of that new Clean Aviation Partnership. And 3 areas have been identified, and you see those 3 here on the left-hand side. First, hybrid and full electric aircraft architectures. Second, disruptive technologies to enable hydrogen-powered aircraft. And last but not least, ultra-efficient aircraft architectures, for example, including new configurations, improved engines, and advanced aerodynamics and structures. So those 3 are the focus areas for the new European Partnership of Clean Aviation. And those 3 focus areas are not to be looked at, as you can imagine, in isolation and independently from each other, because they are closely linked. When you speak about the middle part, for example, hydrogen-based fuel cell technologies and electrical architecture are closely connected. And we are starting now to prepare more technical content, more detailed technical content. We're starting to work on roadmaps how those three topic matters can be developed and over which time frame, which elements, which focus areas should be in the prime target area. And those technical focus areas, as you can see here, they should develop the technologies which are required then for the topic matters further on the right, the regional aircraft, short-range aircraft and short and mid-range aircraft, all by the timeline of roughly 2035. And you see another timeline there further out there if you look at the long-range aircraft, which are coming then a bit later in that graph. Within the next slides, I'd like to now focus a bit on that middle part, on that hydrogen part, and provide you with some insights of specifically on the hydrogen topic. And we have worked in a study together with our colleagues from the Fuel Cell and Hydrogen Joint Undertaking, and also together with McKinsey and lots of stakeholders from the private side, lots of people who we have seen just before on the slide before. And so we have worked on the capability and the viability of hydrogen in aviation. And you see here the different areas and comparing synthetic fuel with regard to impact on CO2, NOx, water vapor, and contrails, and the same for the hydrogen turbine, and the same for the hydrogen fuel cell. And without going into those details now, you will see that there is a significant positive impact of hydrogen in comparison to syn fuel. You see that syn fuel could reduce climate impact by 30 to 60% on the very right-hand side, while hydrogen turbine can reduce the impact by 50 to 75, and if you think about fuel cells, even by 75 to 90%. So a significant impact with regard to the comparison to kerosene, what we are obviously have in use today. There are lots of uncertainties around some of those topic matters. On CO2, it's pretty clear, quite direct, but on the other areas, NOx, water, and contrails, it's less obvious, and we are recommending research to be performed in these areas in order to get more assurance about those elements there. The next slide, please. And there you see some scenario for what we call a full decarbonization by 2050. You see here that in the fields of commuter and regional aircraft with lower range requirements, we see that by 2030, 2035, that quite a reasonable number of those aircraft can be replaced and can be hydrogen powered, can be replaced by hydrogen powered aircraft. For the medium range hydrogen aircraft, we think that's a bit later, around 2040. The long range segment, and then you are moving into the blue part here, that will not see any hydrogen powered aircraft, potentially not before 2050. And those need to be then powered, obviously, by syn fuels or biofuels. In this scenario, and you see that on the right-hand side, we assume that a net zero target for aviation is possible, reducing the CO2 emissions by close to 2 gigatons versus the baseline with only efficiency improvements. 40% of the global fleet would be hydrogen powered. And in addition to reducing the CO2 emissions, this scenario would also see an equivalent CO2 emission reduction by 0.8 gigatons of non-CO2 emissions. So that's why, for us, it's obvious that hydrogen can play a significant role in aviation industry decarbonization. But to get there, we need to invest. We need to invest in research and innovation, and we need to make those technologies as well affordable. Let's go to the next slide, please. And there you see here an aircraft design with 4 major technology improvement areas. You see the liquid storage for hydrogen on board of an aircraft. Currently, the LH2 tanks have an energy density of 6 kilowatt hours per kilogram. That needs to be doubled for commercial aircraft. The distribution of liquid hydrogen is totally unclear at at aeronautics level, at aircraft level. That needs to be researched. The fuel cell systems need to get to a level of 2 kilowatt per kilogram. Absolute power rating of 10 megawatts. Also, that is not available right now. And lastly, also, the turbines are not available to burn hydrogen in turbines. Also, that needs to be researched. So quite ambitious technology developments which we foresee to happen. But what we did based on that, we had some detailed design studies, and we were indicating what type of mission, what type of passenger aircraft could be viable. You see that here on the right-hand side, that we believe that an A320 type aircraft, tube and wing, as you can see it here, might be feasible with 320 PAX numbers, with a length of an A321 to accommodate specifically the LH2 tanks, as you can see here. And by that, we assume that this type of product could have an energy demand which is less, which is reduced by 5%, climate impact reduced by 75%, and no CO2 emission in flight. So that is something we foresee to happen potentially within the next 15 years. But again, before an entry into service around 2035, significant investments are required. The next slide, please. And this is indicating a bit what we are foreseeing over the timeline. 3 major milestones, one around 2028, proof of technical feasibility, first certification rules for commercial aircraft being available, first prototype for short-range aircraft as a requirement for an entry into service around 2035. The second timeline around 2035, then building on the designs, on the previous designs, a medium-range aircraft prototype for an EIS around 2040 seems to be reasonable. And then around 2050, by 2050, the aim should be then to explore how hydrogen could also play a role in the long-range segment. This will require a very different aircraft, potentially and probably most likely even blended wing-body aircraft configurations, which need to be explored, which need to be researched, where the technology is far, far, far away from maturity. So in order to achieve that net zero, these investments need to happen now. And I think that's so important that we are putting those investments together and that we are sharing those investments at European level, because none of those topic matters can be achieved alone. And this is my final 2 slides now. Please go to the next one, where I would like to put your attention on the effort which we need to spend for research and innovation in the next decade. And you see here that we have calculated an effort of roughly 12 billion euros, which we believe is necessary in order to make those technologies, first to identify those, to develop those, to mature those, and then to demonstrate those, as described just before. 12 billion euros. Fortunately, not just by Clean Aviation or Clean Sky alone. These 12 billion is a sum of all the research effort in aviation, dedicated and focused on aviation topic matters all over Europe. So to those 12 billion, Clean Sky and Clean Aviation will contribute. To those 12 billion, we are expecting the private 100% self-invested money will contribute. And we are hoping as well that we can coordinate well with the regional and the member state funding mechanisms in order to have a very aligned view, aligned technical roadmaps, but independent programs under the responsibility of the individual parties, but technically aligned in order to make those changes, those significant and quite revolutionary changes, then happen by, in terms of research, by the end of this decade, and then in terms of development, the next step by 2035 and the following years. And you see here that this 12 billion investment will trigger a 50 billion investment by the aircraft manufacturer and their supply chains, the engine, the systems, the structural providers. So they need to spend 50 billion in order to develop those aircraft based on the technology which has been developed before. And then finally, the airlines need to buy those products. And this will then conclude 5,000 billion of investment in order to buy all those aircraft. I'd like to focus your attention on to the fact that first, we need to significantly invest in research and innovation within this decade, between now and end of this decade. And secondly, that there is a significant return on investment. As you can see here, the 12 billion will trigger the 50, and the 50 will trigger the 5,000 billion. So huge investments also from the private side, not just on the research bubble, but definitely on the bubbles of the 50 and the 5,000 billion in the next decade. Let me please conclude now. Next slide, please. I wanted to share with you that we have used in Clean Sky and all the stakeholders from industry, from SMEs, from the research organizations, from the universities. We have used the time over the last decade to build up a very efficient and high-performing ecosystem in Europe. As I said, close to 1,000 entities, 950-something, around 5,000 scientists and engineers working on it. So really, really high-performing ecosystem on top of the technologies which we are delivering on a daily basis. Second, I think what is very important, following the Green Deal announcement, Europe has formulated an extremely ambitious environmental target. And this is relevant not just for all other sectors, but also for aviation. And what I honestly believe, and that has been shared and is shared as well by the community, that we need a revolution in technology development, not only an evolution. I think we need to continue with evolutionary approaches, yes, but evolution will not bring us there where we need to be. So we need to as well look at revolutionary approaches, and hydrogen, for example, would be one of those revolutionary approaches in order to get where we need to get. What we need definitely is a wide participation of all stakeholders. I mentioned already the private side, but I think what is even as important is to also connect the public side, connect the member states, connect the regions, connect the European Commission and the European Union with all the instruments which are available in order to have really everybody aligned on that common vision and that common goal. And then I think it's also a question of funding, obviously. We have a commitment from the European Commission. It could be still a bit more. Yes, we have commitments locally in the member states. We have commitment from the private side as well. Now we need to orchestrate that commitment, that individual responsibilities, that commitment in order that we have really a common approach into a common direction. I'd like to close, and the next slide, please. I'd like to make you aware about our virtual fair. You see here in the middle a link. Unfortunately, all the air shows we are normally present and we can usually share our results were not happening up to now. And we have established a virtual fair, so please check that one out. You can see experts from the different stakeholders, from the different participants in Clean Sky describing a bit what they have been doing and how they have been doing it. For me, a very, very positive sign in those times where we can't meet physically. Thanks again for listening to me, and I hope you are going to have an exciting next part in the agenda, the panel with hopefully some complementary indications on top of what I've been trying to